Hi guys, our project is about quantum perceptron, or as we like to call it, Qtron. This Qtron is nothing but a quantum version of classical perceptron, which is the basic building block of artificial neural networks. Machine learning and neural networks date back to Rosenblatt's perceptron, and this idea is just taking a leap forward and making it compatible with quantum computers, or we can say a peek in the future. Before going into the details of our implementation, let's do a quick recap of classical perceptron. A classical perceptron is just one neuron. It has different weights attached to it. The number of weights is equal to the number of input parameters. Now let's reformulate this in the language of linear algebra, or in other words, let's vectorize it. We can say that it has one input vector I with n elements and a weight vector W with n elements. The output is then nothing but just a dot product of vectors I and W. Now let's see how a quantum perceptron works. The diagram that you are viewing here is actually a quantum circuit. Quantum computing models depend on these quantum circuits. In these circuits, we have two blocks, UI and UW. The block UI is responsible to prepare the state I and UW prepares the state W, which are just the quantum versions of I and W vectors. We start with n qubit input and our output should produce something similar to the dot product of vectors I and W in classical perceptron. The main advantage of having a quantum perceptron is on space. Classically, if we have n bits, quantum version can have n qubits, but it will be equivalent to 2 to the power n inputs in classical computer. Now let's talk about experimentations and results. We created our own data and labels for training. We trained our quantum perceptron to recognize specific patterns in a black and white image. Our input consisted of 1 and minus 1. For example, one of the input can be 10, and as we can see in this image, the binary representation of 10 is 1010. But in our case, we were dealing with 1 and minus 1s, so our input will be 1 minus 1 1 minus 1, and we can see that this can be mapped to a black and white image containing white color for 1 and black color for minus 1. So this was our data, and after every iteration the weights and inputs were getting closer and closer to each other. It was a pretty good approximation for a first try, and I will say that our quantum perceptron did pretty well. That's all for now. Thank you for watching.